calculus problems from section 8.8. Let's see, what am I doing here? 4 through 20. Where'd my pacing guide go? Uh-oh. 4 through 20 evens. I think that's what I'm supposed to be doing. Oh, I'm not kidding with you here. Pacing guide has disappeared. Well, I'm going to do these. Hope for the best. All right, let's see. Number 4. This is some improper integrals. Of course, the impropriety is you can't have an area of an unbounded region. It's crazy. Turns out you can. So, going to do u substitution here. U equals 1 plus x squared. So du is equal to 2x dx. So I need a 2 here, 1/2 on the outside. So the rewrite looks like -1 plugged in here gives me a 2. Infinity plugged in here gives me infinity. So not ever looking back. That gives me a 1 over u du. And that gives me natural log. And the natural log of infinity is infinity. So this is a bust. Divergent. All good. Number 6. Going from 0 to positive infinity, x e to the negative x squared. Do you feel like you're getting good at spotting these, like that this is a u substitution? Right, because this is x squared and I've got the x there. Hope you're feeling pretty okay about that. Confidence. So it looks like I need a -2 in here, which means I need a -1/2 on the outside. So the rewrite, -0 squared is 0, negative infinity squared is infinity, and the negative sign, that is not getting squared, so that is negative infinity. And then all this inside Garbaggio turns into e to the u. Antiderivative of e to the u is e to the u. And e to the negative infinity means 1 over e to the infinity, which is going to go to 0, so it looks like we're going to get an answer, minus 1. So it looks like we got ourselves an area, 1/2. Number 8. To infinity, you got 1 over x times the square root of the natural log of x. Well, when you're looking for u substitutions, always consider trying the thing that looks like it's the inside. Du is 1 over x dx, and there it is, 1 over x dx. So the rewrite looks like natural log 2, the natural log of infinity is still infinity, and then 1 over x dx, that's all just the du, so it's really just 1 over the square root of u, or in other words, u to the -1/2. So, antiderivative of that, add 1 to the exponent, and then divide by the new exponent. Dividing by 1/2, same as multiplying by 2. And you can bring constants to the outside if you want. And right away, maybe at some point, you're going to realize that taking the square root of infinity, that is not going to turn into anything that converges. So that is a divergent job right there. Number 10. Negative infinity to 3 of dx, x squared plus 9. Well, what do we do here? this looks like, if it's going to be anything, since there's nothing on the top, it's not a u substitution with the with x squared or x squared plus 9, because that's not going to help. I don't have my x on the top. This looks like it wants to be tangent inverse. So my goal would be to turn this into 1 over 1 plus u squared. That's what I would like it to look like. So that 1 right here, that's not negotiable. That means I need to factor that 9 out. So first thing I'm going to do is make that 1/9. Just bring that 9 all the way to the outside. And then, of course, if I factor a 9 out of that, that's going to make that x squared over 9. And I haven't done anything to these yet. So now I would like this right here to be a u squared. So if u squared is going to be x squared over 9, that means u is x over 3, which means du is 1/3 dx. So that means I need a 1/3 on the inside, and that means I'll need a 3 on the outside. Okay, so to go for the rewrite, 3 times 1/9 is 1/3. New limits of integration. Negative infinity, sorry, right here, negative infinity divided by 3 is still negative infinity. And 3 divided by 3 is 1. And then on the inside, I got all my wildest dreams have come true. I turned it into the derivative of tangent inverse. So then when I take the antiderivative, I get tangent inverse. All right. Now, I have an awkward question for you. What's the tangent inverse of negative infinity? Well, that's really, what we're really asking here is what is the limit as x approaches negative infinity of the tangent inverse function. And I'm going to think about this graphically. So if you remember what the tangent function looks like, the middle swoosh of it looks like this. And if you invert it, tangent inverse, we only invert this piece, right? That's where the domain restriction is, so we get a function, would look like these vertical asymptotes would turn into horizontal asymptotes and would get something that looks like this. So as x approaches negative infinity, the tangent inverse function is approaching negative pi over 2. That's where that asymptote is. So this is 1/3. The tangent inverse of 1 is pi over 4. And this is negative pi over 2. So that's pi over 4 plus pi over 2. That's 3/4 of a pi times 1/3. So I'm thinking that's pi over 4. Boom! That's right. Calculus teacher knows how to do calculus. It's a newsworthy story right there. Okay, so that one was a little tricky, I think. Negative infinity to 0, e to the x, or 3 minus 2 e to the x. Now this should work with just a regular old u substitution here, because if I make this u equal to 3 minus e to the x, then du is equal to negative 2 e to the x dx, and I've got that, the e to the x that I need here. I just need a negative 2 now, and negative 1/2 there. Good practice for our u substitutions here, don't you think? So negative infinity here. E to the negative infinity goes to 0, so that'd be 3 minus 0. And then if I plug 0 in here, that's 3, hold on a sec. Back up. Yes, e to the negative infinity is 0, so that makes this 0, and that makes this 3. 3 minus 0 is 3. Sorry about that. And then when I plug the 0 in, e to the 0 is 1, so 3 minus 2 is 1. And then on the inside here, I just have 1 over u du. Okay, now here's an optional move. If you don't like negative signs and you also don't like integrals that are kind of like running the wrong way from 3 up to 1, then those two things can cancel each other out. You can take that negative sign and use it to flip those. That's optional. You don't have to do that. But I'm gonna. So I got rid of this negative sign and I flipped those. That's a move that has come in a pair like that. So I got 1/2 natural log 3 minus natural log 1 is 0. So it's just 1/2 natural log 3. Groovy. Number 14. Okay, so I got the negative infinity to positive infinity thing going on here. So that means, can you convince yourself that this is an odd function? Well, I think it is. So maybe I'll do half this problem and let you do the other half. So I'm going to break it up into negative infinity to 0 and then 0 to infinity and see if I get answers for both of those, then we are convergent. Okay. So let's see. This looks like a regular old u substitution because I got an x squared here and I got the 1 degree lower there. So remember, when in doubt, you just try the what's inside and hope that it works. You need a 2 inside there, balanced by 1/2 there. So the rewrite looks like, so negative infinity squared is positive infinity plus 2 is positive infinity. 0 plus 2 is 2. Okay. And then on the inside, this all turns into u to the negative 1/2, right? 1 over the square root of u. Alrighty. So I'm going to bump the exponent up by 1 and then divide by the new exponent. Well, I have a 1/2 here on the outside, so when I do 1/2 divided by 1/2 on the outside, those cancel out. And the square root of infinity, that's not going to work. So I get the square root of 2 minus the square root of infinity, and that is divergent. And if either part of this is divergent, so the fact I don't have to do the other one, because if either piece is divergent, then the whole thing is divergent. Number 16. Got another one that's going to have to be broken up. So I'm going to do half of it, and I'll let you do the other half to make sure. But you could try to convince yourself that this is a function with symmetry that would allow for us to know that when we have half of it, that it's just going to be double for the other. But I'll let you finish that. Do the other half. All right, so let's see. That, geez, can you spot what this wants to be? I guess this is a little tricky. Is this suggesting to you tangent inverse at all? It's screaming tangent inverse at me. So that's negative e to the negative t dt. So this e to the negative t, I know u is equal to that, but I'm not going to make that a u. I'm going to use that one for the du. And I need a negative sign there, so a negative sign on the outside. Excuse me, so the rewrite, u is equal to e to the negative t. So that would be e to the positive infinity. And then up here, e to the 0, that's 1. And I might do that negative sign, switch those trick in a minute. So on the top now I have du, and on the bottom I have 1 plus u squared. because if you square that, you get that. So that's a little bit tricky to spot that that's tangent inverse, maybe. So I'm going to do that little switcheroo there. So I have tangent inverse from 1 to infinity, and we just talked about that there. The tangent inverse of infinity is pi over 2. That's really asking what's the limit of the tangent inverse function as x approaches infinity. It's pi over 2 minus pi over 4, and that's pi over 4. And then the other side, if you do the integral from 0 to infinity of this, you're going to get blah, 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 repeat all the work. It looks almost identical. You already have the antiderivative and everything. I guess you just have to do this, right? You can just jump in right here. It's also pi over 4, so putting those together, we get pi over 2, which is the answer. Number 18, 0 to 8, we have of, I'm going to call this x to the negative 1/3. And you might be looking at this saying, hey, this is from 0 to 8. This isn't, where's the infinity? Huh? Well, this is undefined at 0. This has a vertical asymptote at 0. So this is an improper integral, not because there's a going to infinity, not because there's an infinity here, but because there's an infinity as x approaches 0, we get a vertical asymptote. That's why. So let's see what happens. So what are the rules there? The rules are not different. You just take the antiderivative and plug stuff in and see if it works out or not. So the antiderivative of x to the negative 1/3 is bump the exponent up by 1 and then divide by the new exponent. Dividing by fraction, same as multiplying by reciprocal. And this looks like we are going to have no problemo. So 8 to the cube root of 8 is 2, squared is 4, and the cube root of, that's just 0. So what's that, 6? Oh, that's hilarious. I'm just looking at the screen now. That entire problem was off screen. Sorry about that. There it is. That was an easy one. And then same thing here. This also has a vertical asymptote. To write it like that at 4. So what happens here? This is an easy, you don't really have to do a u substitution because it's just a negative sign there. So the antiderivative of something to the negative 1/2, add 1 to the exponent, and then divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2. And then the negative sign because this was a negative x, right? So I'm like dividing by negative 1 there. You can write out a u substitution there if you like, if that makes you feel better about it. Totally fine. All right, so we have 4 minus 4 is 0 to the 1/2, minus 4 minus 0 is 4 to the 1/2, which is 2. So that's negative 2 times negative 2, which is 4.